We are Group 1 and we are working on a smart water probe interface. My name is Alex Watson and I worked on the power supply.
My name is Josh Smith and I worked on the PCB design.
My name is Yiqi Liu and I work with Alex in power supply.
My name is Justin Westfall and I worked on the probe detection circuit and the embedded software.
The problem that our project is solving is that right now the product that Pentair has is very limited. It can only support one type of probe, which requires 5 volts. Our module is designed to be smart so it knows what's being hooked up and it can supply the correct power to whatever device this module is being provided at the current time. This adds a lot of flexibility to Pentair's design.
So to go over how it works, basically we're going to connect the battery to the probe to give it power. And if you look here, there'll be a yellow LED pulsating. And what that is an indication of is that our circuit is trying to detect whether a probe is connected to it right now. As you can see right now, the blue LED is on our circuit, and this is a direct indication that the LUMI 4 has been detected, and it's already outputting 7 volts at its power inputs. And as you can see, 6.95 volts is as close as it's going to get. It's a digital controlled output, and it's well within the spec that we were asked of in this project here. And so now we're going to connect the TGP, which is a 5-volt circuit, or a 5-volt probe that takes 5 volts. And as you can see, the green LED is already on. It's a very fast detection process, which helps with the end user just plugging and playing their product, and such that there's no delays that they see at all. And if we look on the meter, will show up about 5 volts. This is all basically, part of the fact that we want to make this as plug and play as possible. The end user, we're not adding any buttons, any software controls. It's very much as soon as you plug in the probe, it's configured for the correct voltage. So it seemed like the biggest challenge was the fact that the overall scope of our project is detecting a probe and outputting the correct voltage. But the question is, how do we detect a probe and how do we do that? So what we ended up coming up with is the fact that we want this resistive current sense circuit, which is fine, but now we have to sort of design this switch circuit as well. And it turns out that higher than the rails ICs aren't very available on the internet. We did some searching, we found parts that were either too expensive or weren't spec for what we wanted, so we ended up doing a discrete MOSFET design for that sort of thing. And overall, that's part of that fact that we're trying to come up with an actually software-controlled aspect of it. It's very easy to have a button here or there, but to have it be totally based on the pins and the power points of the probe, that was the hardest thing to come up with. The most important project management skill for us was probably communication. It's very important that we're all aware of who's doing what's happening this week, and what needs to be done. And so what our group utilized really well is GroupMe, a sort of mobile chat messaging system. Basically, it's very easy to say like, hey, this worked this week, or we need to check this out, or we need to schedule a meeting. We were both very informed about what we're doing as a group, thanks that there's a mobile app for chatting amongst ourselves. And then the other aspect of this class that we came in contact with was Gantt charts, which I've never messed with them before, but they are a very important tool for scheduling what you need to do per week. And we use those several times as a group for communicating amongst ourselves what we need to do, as well as communicating to our sponsors and other people in the class what we're doing and what we plan to do. So those were all both very important aspects of this class in terms of project.